So let's have a look at this area and algebra question from the Junior Cert Higher Level 2015 Sample Paper 1. So it's question 9, and we're given a plot of land consisting of a garden that measures 8 meters by 10 meters, surrounded by this grey path here of unknown width. Now the question is going to be to find the width of this garden, and 3 students, Kevin, Elaine and Tony, have been tasked with this problem. So they've all been told that the width of the path is x. They've also been told that the area of the full plot is equal to 143 meters squared. So the garden plus the surrounding path is equal to 143 meters squared. Kevin divides the path into 8 pieces, and he writes down the area of each piece in terms of x, and then he's going to form an equation by setting the area of the path, the sum of all those individual 8 pieces, plus the area of the garden, and he's going to let that equal to the 143 meters squared, the area of the plot. So the first thing we want to write down is, well, what's the formula for an area of a rectangle? So because Kevin is going to divide his shape up into rectangles, we want to know what the formula for a rectangle is, and it's the length by the width. This formula is not in our table, so it's something we have to learn off before we go into the exam. But it's also a formula that satisfies the area of a square. So if we think of a square, it has length and width as well, but the width of a square is also its length, and so we can say that it's its length squared. So Kevin divides the shape up as follows. So we can see the 8 pieces, 1, 2, 3, 4, 5, 6, 7, 8. So if we individually go and find the areas of those pieces, we can see that the 4 corners are squares. They measure x by x, so they're all equal to x squared. The areas on the top and the bottom both measure 8 by x, and so their area is 8x. And then the 2 pieces on the side, they measure 10 by x, and so their area is 10x. So the final area in Kevin's diagram is an area that just has the 2 numbers 8 and 10 attached. So the area of the garden is 8 by 10, which is 80. So we've written the area of each section of Kevin's diagram in terms of x, and we've also included the 80 that goes in the middle that represents the area of the garden. So the B part then asks us to simplify the equation that Kevin should get. So Kevin is going to add the 8 grey pieces of his path to the area of the garden and let it equal to 143, the total area of the plot. And if we do that, we can see we have the 4x squareds, we have the 2 8x's, the 2 10x's, plus the 80 of the garden, and we're going to let that equal to 143. If we simplify this, we get 4x squared. If we add 8x, 8x, 10x, and 10x, we get 36x. And then if we subtract 143 from both sides, we get 80 minus 143 is minus 63. So our quadratic equation is 4x squared plus 36x minus 63 equals 0. In part C, we're going to take a look at how Elaine broke down the problem. So Elaine went to write the length and the width of the plot in terms of x. So starting with the same diagram, if we take it that the width of the plot is the 8 meters of the garden plus the 2 x's that represent the width of the path, we can say that an expression in x for the width of the plot is 8 plus 2x. Similarly, the length of the plot will be 10 meters, the length of the garden, plus the 2 x's that represent the path on either end. So an expression in x for the length of the plot can be written as 10 plus 2x. So Elaine wrote down that the width of the plot was 8 plus 2x and that the length of the plot was 10 plus 2x. In part D, we're going to write down and simplify the equation that Elaine should get. So Elaine is going to multiply the width by the length from the area of a triangle and let it equal to the full area of the plot, which is 143. So we're going to multiply 8 plus 2x by 10 plus 2x and let it equal to 143. If we open up the brackets, we get 8 on 10 plus 2x plus 2x on 10 plus 2x equals 143. So 8 by 10 is 80, 8 by 2x is 16x, 2x by 10 is 20x, 2x by 2x is 4x squared equals 143. And if we simplify this in the form of a quadratic equation, we have 4x squared plus 36x. And again, if we subtract 143 from both sides, we get minus 63 equals 0. So we have the same quadratic equation that Kevin came up with in part B of the question. Part E asks us then to solve an equation to find the width of the path. Well, both Kevin and Elaine came up with the same equation, 4x squared plus 36x minus 63 equals 0. So this is the equation that we'll use. Ideally, the best way to solve this is by factorising, and we'll do that in a second, but if we were stuck, we could always use the minus b formula, which says that x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. So this formula is in our tables. With this quadratic equation, a would be the number 4, b would be the number 36, and c would be the number minus 63. And we substitute those into the formula, and we'll get two values for x. So the preferred method to solve a quadratic is through factorization, if possible. So two sets of brackets equal 0. The first term in each bracket could be 4x and x, or 2x and 2x. So we'll try 2x and 2x. The second term in each bracket have to multiply to give 63. So we could have 7 and 9, 63 and 1, or we could have 21 and 3. The last criteria that has to be satisfied is that the inside terms, 42x, and the outside terms, in this case 6x, they have to somehow combine to give plus 36x. If we had a plus 42 and a minus 6, we get 36x. So the outer terms, they give you the minus 6, so we give them a minus, and the inner terms give us the 42, so they get a plus. This method is called trial and error, so we double check our answer just seeing does it satisfy the three criteria. 2x by 2x is 4x squared. 21 times minus 3 is minus 63, and 42x minus 6x is 36x. So this method is called trial and error. If 2x and 2x hadn't have worked, we could have tried 4x and 1x. If 21 and 3 hadn't worked, we could have tried 63 and 1, or 7 and 9. So once our quadratic has been factorized, we let each bracket equal 0. So 2x plus 21 equals 0, and 2x minus 3 equals 0. We solve for x, so 2x equals minus 21, x equals minus 10.5, 2x equals 3, x equals 1.5. In this question, x can't be a negative number as we're measuring length, and so this is not a valid solution. And so the only valid solution to the question is that the width of the path x is equal to 1.5 meters. The F part of the question takes a look at how Tony went about solving the problem. So Tony didn't solve the problem using an equation. Instead, he tries out various values of x. And so we have to show some calculations that Tony might have used to solve the problem. So we make the assumption that Tony agrees that the width is 8 plus 2x and that the length is 10 plus 2x, as in Elaine's calculations. And so he's going to try various values of x, so that when you multiply the width by the length, you get the value for the area of the plot, which is 143. So we can only assume what Tony's guesses were. So let's take a value of x equals 1 and sub it into the area formula of length by width. If we sub in x equals to 1 and we multiply it out, we get that the area is 120. So when x is equal to 1, we get an area that's too low. So then we can only assume that Tony tried a value that was bigger than 1. So let's go with x equals to 2. He subbed this into his formula for area. He multiplied it out and he got a value of 168. So this was too high. Remember, Tony is looking for a value of x that will give him 143. So he selects a value that's between x equals 1 and x equals 2. So Tony selects x equals to 1.5. If we sub in x equals 1.5 into our formula for the area, we get 143, which is the correct value for the area plot. And so Tony knows that the width of the path is x equals to 1.5. So the final part of the question, part G, asks us which of the three methods do we think is the best, and they want a reason for our answer. So the method I'm going to select is Elaine's method. Elaine's method is direct and accurate, and it takes the fewest steps. Kevin's method was very accurate, but it was a little bit time consuming in that he had to break up the shape into various parts. And then Tony's method, by trial and error, may or may not work depending on the value of x. If x had been a decimal to another number of places, Tony may never have landed on the correct answer.